So now that we've talked about what reactive programming is, and we've talked a little bit about the Reactive Streams API, let's take a look at a couple of popular implementations of the Java Reactive Streams API. In particular, we're going to talk about Project Reactor and RxJava. The Java Flow API by itself isn't very useful. This is a somewhat whimsical example of useless things. So this would be a very useless wine glass where you drank from it and it would drip down your shirt. This would be an example of a rather useless fork that was on some kind of chain, or a key that had a flat head. All useless things. And I would argue that the Java Flow API by itself isn't very useful, because there's so many things you'd have to do to make it worthwhile that you probably wouldn't apply that particular formalism. However, it does provide a useful service because it provides an interoperable foundation that is then implemented by other popular reactive programming frameworks like Project Reactor and RxJava. Reactive Streams implementations, such as RxJava and Project Reactor, enable the insertion of so-called event transformer operators between publishers and subscribers. Remember, the key themes, the key abstractions in reactive programming were publishers on one side and subscribers on the other, and there could be one or more, or zero or more, and so on, of publishers and subscribers. And they would generate events. What the reactive stream implementations do is they make it possible to put transformers in between publishers and subscribers, thereby having this pipeline effect to transform the events as they flow through the pipeline. So you can kind of think of this as like an assembly line where things flow through it and they're transformed. That, by the way, should look quite familiar at this point, because that's essentially what Java Streams does as well. In fact, that's what we see on this slide. You can think of these transformers as being very much like those kind of filters or transforming agents in some kind of water purification system or the Java Streams framework and so on and so forth. So this should all sound very intuitive at some level. Reactive Streams programs and programmers very rarely use the publisher, subscriber, and subscription interfaces from the Flow API directly, but instead they use classes that implement those interfaces. And there's a bunch of classes, and there's two different frameworks. We're going to focus primarily on RxJava, but I'll mention the other ones in passing. So RxJava has almost a half dozen key classes: completable, maybe, single, observable, and flowable. And Project Reactor only has two, has mono and flux. There's pros and cons to each approach. RxJava came earlier than Project Reactor, and so there were some lessons learned in Project Reactor that are not integrated as cleanly into RxJava because they came first and they had to endure the slings and arrows of being the pioneers with the arrows in their back. For Project Reactor, there's something called a mono, which will either complete successfully or fail. It's kind of like an asynchronous optional. And there's a nice example you can find in my GitHub repository that shows how to use monos. There's a whole slew of examples actually in that folder that do that. There's also something called a flux, which, unlike a mono, will emit an indefinite number of events from 0 to infinity, either completing successfully or failing. And this also supports something called back pressure, which is a form of flow control that ensures that a fast publisher can't overwhelm a slower subscriber. And there's a nice set of examples here in this folder that show how to do that. Moving on to RxJava, which is really our primary focus in this class. The first class is called single, which is basically very similar to a mono, and it either completes successfully emitting exactly one item or it fails. And there's some cool examples of that. We're going to look at a bunch of those as we go through the course. There's also something called an observable, which is a bit like a flux, which emits an indefinite number, either 0 to infinity, which will either complete or fail. Observables don't support back pressure. So when things start going, they go as fast as they possibly can, and it's up to the subscribers to figure out how to keep up with that. And there's a bunch of examples of observables that we'll talk about. Because people who did RxJava realized there were some limitations with not having flow control, they later added another class called a flowable. And the flowable is very much like a flux in that it emits an indefinite number of items from 0 to infinity, which either succeed or fail, but it does support back pressure. And it also supports some other cool things we'll talk about later having to do with parallel processing, as does flux. There's also, I didn't really talk about them, but there's also a couple of other RxJava classes, completable and maybe. And completable is kind of a weird, wacky thing that actually turns out to be useful in a few cases where it either completes successfully or with failure, but emits no value. And it's kind of similar to Java's completable future to void mechanism. It just says something's done, not going to tell you what it was, but it's finished. And then there's this thing called a maybe, which either completes successfully or with failure and may or may not emit a single value. And that's similar to a mono. So we'll see examples in this class of completables, maybes, singles, observables, and flowables, and you'll get a chance to program them when we start with assignment 4A here shortly. So that's the end of the quick overview of popular implementations of Java reactive streams. Again, we're going to focus primarily on RxJava.